Hey, it's Peter from DevMentors, and at first, let me welcome you in 2022, the new year. So, great to see you guys in this new year, and great to see you in the fourth episode of Building FeedR, our .NET 6.0 microservices related series. So, in this episode, what we are going to do, is to focus on our very first so-called quotes microservice and our quote suite, and we are going to implement the pricing generator. Alright, before we move on into the episode, to the main topics of this episode, I've got a great news to share with you. So just like yesterday, together with a friend of mine, Darek, the second DevMentor, we have finally released our full, comprehensive, modular monolith course in English. So you can check out our DevMentors.io platform, and for the first buyers, we've got some great discounts here. So make sure to check this one out, the modularmonolith.net website or .com website and our DevMentors.io platform. And if you are not familiar with modular monolith, feel free also to check out my mini course that I've recently published into our YouTube channel. Alright then, so let's get into the main topics of today's episode, the fourth episode. So like I already said, what we are going to do today is to actually prepare for the future episodes, meaning that we will work on our very first component called the pricing generator, which will be responsible for kind of mimicking what you would typically see in some kind of, for example, pricing related system, right? So we want to have some kind of, eventually in one of the next episodes, some kind of maybe data stream that we could subscribe to, whether as a separate microservice, for example, our aggregator microservice, maybe we like to consume some kind of pricing data as a data stream, or maybe from the consumer's perspective, maybe we like to purchase some subscriptions in our app, so that, for example, you could sell subscriptions to the users of your API, and then they could subscribe to this almost like real-time data feed. So in this episode, we will not stream data, let's say, over the network layer yet, but we'll work on this pricing generator component so we can actually prepare ourselves for the future episodes. Alright now, so let's jump back into our solution and let's see what we are going to focus on. So within this episode, we'll jump into our feed called this quotes feed. And what we want to implement here is some kind of the, let's say, pricing generator. So the idea is that, for example, if you were, let's say, to search something like the currency pair, let's say your USD or your GBP, you would find this kind of so-called currency pair being the ratio between these two currencies. And as you can imagine, people all around the world are using this information, for example, to make some trades. So in our case, of course, we won't be plugged into some, let's say, real terminal, or maybe we won't be plugged into some MetaTrader or Forex server. So we'll try to generate this on our own as some kind of dummy mock data, but we'll see how later on, for example, in the future episodes, we could, for example, stream this kind of data to some other services or maybe to the clients of our system. So let's start with the definition of our models, our basic entities. So under the quotes, I'll just maybe make a separate directory and I will call this one the pricing. And here, let me just create a new subdirectory and I would name it, for example, model. So we'll keep things as simple as possible. And let me just create here something like the currency pair. All right, so this will be our entity, our model. So I will make this one to be of a record type because I don't even need a specialized class. Of course, behind the scenes, this is going to be the class anyway. And here I would like to provide three properties. So our symbol, let's say Euro USD as a pair, the actual value, and then let's say the timestamp. So since we want to be pros, we are going to use our timestamp as the long value based on this epoch Unix timestamp. All right, so this will be our data model that we would like to stream maybe later on to some other services or to the clients of our system. So the question comes, how do we actually make this generator work? Like I said, we want to have some kind of internal, ideally background generator that will be able to just produce these values in some way. So what we are going to use is the following. We are going to make use of this actually well-known and very mature interface and then a class called the I-hosted service. So the I-hosted service is been part of ASP.NET Core for quite some time now, and this allows you to make this background jobs without the need of installing, let's say, packages like Quartz or Hangfire that you might find useful for more advanced stuff. So let's start with the following. I'm going to make a new class here under this new services directory, and I'll call this something like pricing background service. And to begin with, I'll make this one simply implement the interface called I-hosted service. Okay, so this is what we are going to start with. And as you can see, it has two methods there, start async and then stop async. So simply for now, I'll just leave this empty so we can see how to plug this in, and we can just add this to our IOC container. So let's jump back into our program.cs definition, and here before we build our app, before we build our IOC container and before we get this instance of our service provider, let's just invoke the builder services, and then I'm going to call add hosted service and provide our pricing background service. All right, as one of the possible many classes that might implement this interface. So this is what we are going to start with. And of course, when we run the app, we are going to hit this endpoint, and when we gracefully shut down the app, we are going to hit this stop async. So it's important you to know that sometimes in some scenarios, your application might be killed, like brutally killed, whether this would be something like, let's say, kill or kill -9 command from your terminal or from your orchestration engine or from your server where you are hosting the apps. So just be careful that if you have some kind of, let's say, cleanup logic defined here, it might not always be invoked if someone just terminates your app without allowing it to gracefully shut down itself. So the next thing that we are going to implement is actually our, let's say, the generator component. So let's start with something simple. I'm going to provide here a new interface, and I'll call this something like iPricing generator, like this. And for now, I will expose here two methods. So the first method will be just simply called start async. And the second method, as you can imagine, will be called stop async. All right, so we want to be able to run this generator in the background. And for example, when we stop the app, we want to be able to just stop this generator. All right, so let's jump back now into our background service. And here, let me just provide this instance of this non-existing implementation yet, but I'll just provide it for the DI, for the constructor. So here, let me just provide it like this. And as you can imagine, we can call our generator start async here, and then our generator stop async here. So whatever the logic of the, for example, stopping our generator will be, it will be, for example, called somewhere here, and whatever the logic of such a generator would be, will be called somewhere here. All right, so we could call it somehow within our background service, and this will be done by the framework itself. So now let's try to implement our pricing generator, right? And then I'm going to make it something like this. And now let's think about generating our dummy data. So let's see how we can, for example, generate some kind of currency pairs for our pricing stuff. All right. So let's start with something like following. So at the very beginning, we could declare some kind of, let's say, static data for this stuff. So let's imagine that we might have something like a dictionary. So I'll make here a private dictionary, and I'll have this the simple mapping between the string and the decimal. So this will be our, let's say, currency pairs, whatever we are going to call this. And let me just instantiate the new instance of the dictionary. And here I'm going to provide, let's say, a few currency pairs. So let's say I'll have this EUR USD equals to, it was 1.13. as money, being this decimal type, and then a few others. Let's say the one for the British pound, let's make it 85, as at least that's the current value for this day. Then we have the CHF, and this is going to be about this one, and then we have our PLN value, which is going to be something like this. All right, so we have a few currency pairs, and of course you can imagine we would provide here many more currencies, based on currencies from all around the world. But this will be good enough to start with. So now let's move further, and let me just inject here the logger so we can actually see that some stuff is going on behind the scenes. And I'll just provide here our logger instance for the generator. So let me just provide it like this, and of course without this guy in here. So let me just inject it here. And now let's think how we could actually start running our generator. So what I will do, since we have these two separate methods here, start and stop, I will simply add some kind of Boolean flag. All right. We could, for example, go with something like the cancellation token, and then since we have a task, we could just, pass here the cancellation token and then just cancel the task. But we can also do it another way. So let's imagine this will be some kind of background loop that we can either turn on or turn off to make our generator, run or stop running. So I will, let's say, make a very simple flag. Let's just call this as simple as is running, and this will be either true or false. And within our stop async, I'll simply set is running value to be false. So if for any reason I would need to, let's say, maybe clean up some database or do whatever, I do some additional stuff here, I would of course, provide this code here. But since this is going to be more like a synchronous code for now, I can just do it like this and return the completed task from this stop async method. So now let's jump back into our start async. And what I'm going to do here is simply make a loop. So while this is set to be true, I'm just going to make here a loop. So since we have this, let's say, hard-coded pricings already in place, let's try to do the following. So until this is running, which can be controlled by this or this method, I'm just going to iterate through each of our symbols. So for each symbol and the current pricing, so within our currency pairs, we have this symbol and the current pricing, let's say the initial value. I'm just going to loop through it. And then since I, let's say, want to mimic some kind of, let's say, later on streaming scenario in which maybe I'll be updating these values every second or every, let's say, 100 milliseconds or every 5 seconds, whatever the timing is, somewhere here at the very bottom within our for each loop, I'm just going to make this await and then task delay. So I'll just mimic this, let's say, delay between getting the next values. So let me just do something like task delay and then the time span, and then from seconds, let's say every 1 second, I'm going to provide the new values for our currency pairs. And then since there might be multiple currency pairs, and maybe I'd like to be able also to stop our generator while it's already running, while it's already within the for each loop. So I can do as simple as if someone maybe in the meantime disable this by calling this stop async. If it's not running anymore, I can just return from this method. So that's my additional, let's say, return statement here if needed. And now let's see how we can get some new pricing data. So we want to incrementally, let's say, update the values. So in order to make it as close to reality as possible, but still like a dummy way, just to see that these values might change a little bit over time. So let's try to implement a very simple method to get our so-called next tick, next value of, let's say, the current currency pair that we are interested in. So I'll make a method here, and let's call this one next tick, get the next value of our currency pair. And this method, well, this is going to be purely random, all right? So we can declare here something like a random field. So let's make here a new random field, random, new random. And then within our code, what we can do within this next tick, let's at first see if we want to add the value or if you want to subtract the value, so let's say we'll have this very simple random switch for the next sign, the sign whether this is plus or minus. So I will see if this is going to be a plus or minus. So I want to pick the random value between this range. And of course, if let's say this is going to be equal 0, then let's say the signature will be I will subtract the value. So this will be -1, otherwise this will be +1. All right. So this is going to be our plus or minus randomness. And then let's make a next tick. Let's say, let's get a next value for our current currency pair. So I'm just going to call our random and then next double. So a very small value. And then in order to make it even smaller, maybe I'll just divide it by, let's say 20 or 50 or 100 to make these ticks to be very, very small, let's say closer to the reality as much as possible. And then finally, I'm just going to return our signature, signature being plus or minus, and then multiplied by this actual tick value. So here, let me just do this multiplication of the sign by the tick, just like this. So this will be our simple method responsible for generating the next values. All right, so that's it. And now let's plug it in. So here what I can do is something like, all right, so give me the new pricing. So the new pricing will be simply our tick. So at first the tick will be get tick or next tick. And then the new pricing will be just pricing, the current pricing plus our tick, all right? Plus our updated value, whether this was added or subtracted from the most recent pricing. And then I can simply update our pricings. So our current pricings will be the currency pair for this specific symbol will be now equal to the new pricing. So this value. And now I can maybe, for example, log this somehow, right? So here, let me just do something like logger and then log information. And let's just say updated pricing for, and then our symbol. So there will be our symbol here. So taken from our dictionary. And then let's say our original pricing, right? And then the new pricing, which is the updated value after getting and assigning this tick here. So the new pricing with this fixed point to string formatting. And then we can also get, for example, our timestamp. So I could do something like the timestamp. And since you want to be pros, like I said already, I'm just going to use this datetime offset and then UTC now, and then our Unix time milliseconds, so we can be more precise when this actual update happened. And also here within the logs, maybe let's just provide here what was the incremental change. So what was this small tick value, whether this was added or subtracted from the original pricing. And now that's pretty much it, all right? So we have this generator here. We have our pricing data. So theoretically, what we can do is something like the currency pair equals to new currency pair, and then we could provide here our symbol, and then our value, which is new pricing, and finally our timestamp, right? And with this currency pair in place, we could, for example, think of streaming this maybe further, or maybe publishing some events, whether internally or externally to the other microservices. But we'll get to that in the future. For now, let's just leave it like this. We have our generator already prepared in place. So let's see whether we can actually make it somehow work, right? So this looks good. Now, of course, we need to remember that we now need to register our generator within the IOC container. So somewhere here, as usual, we simply can call something like maybe @singleton. And this is the question, whether it should be a singleton or not. We will try to, let's say, make use of the singleton because let's say we want to have only a single instance of this generator being somewhere up and running within the whole application. We don't want to, let's say, make multiple generator instances with different values. We want to have this single source of truth. So I'll just register this as a singleton within our application. So we have our generator in place, which is able now to generate some dummy data. And we have our background service in place, which should be now able to start our generator and later on stop it. So now let's actually run the app. So let's try to run our FeedQuotes service. And let's see if this is going to run as expected, okay? So I'm hitting the run, and let's see. All right, so as you can see, it's up and running, right? But if I try to now, for example, invoke my service URL, let's say this one, I can see that, well, the connection is rejected, right? So for some reason, the application hasn't started, right? And the reason is that we told our background service that we want to start this task when the application starts. But since this is, let's say, a long-running task somewhere in the background, well, this will, let's say, overtake our bootstrapping process, because this is, as you can see, never going to end, right? It will be running infinitely until we set this is running flag to be false. So for now, just to make sure that we can start our service as well, what I will do, I'll just simply tell our background service to run it somehow, let's say, in this background mode. So I will simply just run this task and I will discard it, right? So ideally, I would start this task for some factory of the tasks and set it to be long running. But for now, just to see if, just to keep things simple, I'm just going to discard this task. All right, and this should run. This should allow us to run our app anyway. And then we'll see how we can refactor this to make it a bit better. So just let's see if this is going to help. So let me just change this line of code to look like this, to discard this task, and let's just run it. And let's see. All right, so you can see our generator is up and running somewhere in the background, so it's all good. It's changing this values through this tick generator dummy method internally, and our microservice is still available. We can access its endpoints, so that looks good. All right, so now the question is, what if we would like to somehow, for example, control it? Let's say we would like to have some kind of an endpoint, maybe from our, maybe exposed by our API here within this code suite, where we could call something like start or stop. And then we could control the execution of this background task, all right? So I'd like to be able to somehow reach this, start and stop methods within our background service, within our hosted service implementation. And I'd like to be able to control, as let's say, the user or administrator of the service, whether this generator should be actually up and running, or whether I would like to terminate and maybe in a few seconds restart this generator. And everything, and of course, everything should be happening while our application is up and running, right? So somehow we like to control it through our web API. But as you can imagine, this is the context of HTTP request. So from here, I do not have the direct access to something which is running in the background, right? So let's imagine that I would declare two endpoints there. Let's say map post and then pricing.start, start. And this would somehow be responsible for running our background service. And then the second endpoint, something like, let's say, pricing stop, and this will be responsible for stopping our background service. So how can we actually reach this background service, this hosted service? So the first thing that we are going to do is that we are going to change this from the iHosted service to be actually deriving from the so-called background service. So the background service is once again just an existing iHosted service instance, but allowing us to actually implement easily these long-running jobs. So it's not just about doing something when the application starts and then when the application stops. It's more about doing something periodically in a background. For example, within some interval, or maybe plugging in your service to pull or receive the messages from the message broker, or to call database every few seconds and do some calculations, right? So this is more about providing a code, as you can see within this execute async method here, which is an abstract method, and providing the code here to run this periodical tasks. So let's change this from the hosted service to our background service. So we have this method to actually implement here, this abstract method that we need to override. And now let's try to think how we could actually send some requests from this start and stop web API endpoints to, let's say, this place. All right. So I would like to do some maybe simple if statements. If I get some request and it hits this method body, I could either control whether this task should be started or whether this task should be stopped. So the way that we can achieve this, and it's been one of my favorite components, and I'm still like kind of surprised how many .NET developers out there is not really aware of this very nice API component, is called the channel. So let me introduce a very simple component, and that I'm going to call something like, let's say, pricing request channel. All right. So just some, arbitrary class that you can add. And then within this component, I'm going to declare one property of the channel type. So there is this channel of T, and this will be our channel of some data to which we can push the messages, right? To which we can put some data, and then the other side, let's say the consumer side, can read the data. So we can have a channel where we have, for example, a single or multiple producers, and then we might have, for example, a consumer on the other side of a channel, which is, and all this stuff, which is great, is thread safe. So we have this, let's say, thread safe kind of a queue for the internal messaging between our components. And this will be of great use because here we could use this channel to, for example, push the message here from our web API perspective and then receive this message here internally within the scope of some background job running, let's say, on some background thread out of the HTTP context, HTTP request scope, but still we'll be able to easily communicate our, let's say, end user making requests to the web API and then passing further this user request to our background job running somewhere here within this background service on some background thread. All right. So let's declare our channel. We'll make this implement some kind of a T. We'll see what this T can be in a moment. And let's just call it something like request. So I will have this channel called the request channel. And then I will make a new instance of this channel. So simply you can pick between bounded or unbounded. So we'll make this the unbounded. So there is like no limits, as you can see. But if you like to put some hard limit, maybe for the number of messages that you can put into the channel and all this stuff, maybe you like implement some kind of back pressure mechanism to how to deal if there's, let's say, too many messages in the queue, how to deal with this kind of scenarios, then you could pick this bounded and, for example, create a channel with this maximum capacity. But in our case, to keep things simple, I'm just going to make use of this unbounded channel. And this will be, of course, of some kind of T. So here, let's imagine that we would like to somehow differentiate between starting and between the stopping. So we would like to maybe accept one of the two possible requests or the so-called commands, so we could, either start or stop our generator. So let's introduce here a new directory. I will call this one, let's say, request. And within our request directory, let's start with a very simple marker interface. So I'm just going to call it like pricing request, all right, or just request, whatever. And this will be purely a marker interface, right? So I just want to have this generic constraint for our additional request types. So we can already mark our channel as the data underlying data type to be of this pricing request. All right. So we'll have the channel with some possible request, and whatever implements this interface can be treated as the message that we can send, that we can actually put and then, let's say, pull, receive from the other end of this channel. So we will send the message to our channel, write the message to the channel, and then we'll receive the message from the channel. So let's add two simple requests. So I'll make a new class here, or a new record once again. So simply something like the record, and I'll call it start pricing. And this will, of course, implement our pricing request like this. And then let's make another one, stop pricing. All right. So if you are, for example, familiar with the, let's say, CQRS or command query responsive integration, If you are not, I encourage you to check out the direct course once again, as I already did in one of the latest episodes. But you could think, for example, of this separation of concerns. So we have this, let's say, command for starting the pricing generator, and then we have, let's say, additional command for stopping the pricing generator. So just some kind of the dummy structure. Of course, we can enrich this with some properties, right? Because this is a record, this is a class behind the scenes. So if you like to, for example, to, let's say, receive this data here, right, within your, for example, post method like this, start pricing, right, and then somewhere here request, then it's okay. You can just put it here, and then you would receive this data, and you could bind some additional parameters, some body to this record, as long as you have, of course, some additional properties declared within your record structure. But we'll keep this simple. As you can see, starting or stopping doesn't really need any additional parameters within, so this will be purely responsible for either somehow calling this or this stop async methods within our pricing generator. So we have the pricing request interface. We have our two, let's say, commands for starting and stopping the pricing generator components. So now let's see how we can plug this in. So at first, let's jump back into our program.cs, and here I will ask our IOC container to provide us the instance of our channel. So please give me our channel instance. So this is it. And now I can do something as simple as channel, and then there is our single channel for our iPricing request, and then we have these two properties, the reader or the writer. So I'll be the writer. I want to write some message into this channel. I want to put some data here. So I'll call this write async, and I'm just going to provide this new start pricing, all right, my record instance. So that's it. And then from my API, I can return something like, for example, results, and then, for example, okay, just like this, or let's say accepted, whatever makes sense for you. So let's say I'm going to return the okay, and the same stuff for our pricing stop. So here I will simply provide here the stop pricing, and once again I'm going to ask our IOC container for the pricing request channel instance. All right, so start pricing and stop pricing here. So we have these two methods. So this is our writer side. This is our channel producer side, right? As you can see, quite easy stuff to send this message, put this message into our thread safe channel. Now let's jump back into our pricing background service. So I'm going to jump here, and then what I will do is the following. So from our, I'll ask our IOC container to actually give us an instance of our pricing request channel like this. So there's our channel, and let me just assign it to this private field. And within our execute async, what we are going to do is the following. So we are going to make use of this async variable. So I'm going to call this await for each, and I want to just asynchronously grab the data from our channel by calling our channel. And then as you can see, we have the reader side, and then there is this read all async method, which returns to us an instance of async enumerable, this iterator, this asynchronous iterator enumerator for our enumerable instance. So I can do it this way, and then I'll be asynchronously iterating through the data, which is being asynchronously sent to our channel, and it's all thread safe. So it's really cool. So what I can do now is something as simple as, for example, let's make this very simple switch there. So I'm going to once again discard this task for now, and I'm going to just make a switch on top of our request object. So let's check what's the actual request object instance type. So if this is going to be our start pricing, all right, then I'm going to call our pricing generator, and then let's say start async. And if this is going to be stop pricing, then I'm going to call our generator and then stop async. Otherwise, if this is any other request, because for now we have only two requests, but as you can imagine, we might add additional requests here. For now, I'm just going to, let's say, discard it, ignore it. So for any other request object, I'm just going to return the task, or I could, for example, log some data here or throw an exception, whatever makes sense for you. So for now, I'm just going to leave it, and let's see if this is going to work. All right. So I'm just going to put a breakpoint here and there, just like this, and I'm also going to put a breakpoint here within our program CS. Let's say there and there. And let's run this in debug mode and let's see what is going to happen. And of course, remember that we need to add our channel to the IOC container. So once again, since this is a thread save, I'm going to register it as a singleton. So just like this. Now let's run the app in debug mode and let's see what will happen. So I'm running the app and let's see. Application is up and running. And of course, I can reach my URL, which is great. So now, let's jump into our VS Code, and here under this fits quotes, I'm just going to make a new file and let's just save it as our, let's save this file here. So I'm going to copy this FeedR file under our quotes, and I'm just going to call it, let's say, quotes.rest. So the URL to our quotes is going to be 5040, the default URL. So I can now get our hello world, right? So this is our base URL for the FeedR quote service. And now I want to make 2 endpoints here. I want to add these 2 definitions for the endpoints here. So the first one will be post to our URL and then pricing start. And then the second one will be post to URL and then pricing stop. So let's see what happens when I call this one. So there is our request. And we are getting the instance of a channel, as you can see here. And now let's move on. So I send a message to the channel. As you can see, the API already, let's say, returned some response. And here, my background service received this message and it started it started our generator, right? So somewhere in the logs, I can see that the generator here is up and running. And now I can do something like stop. And once again, I'm calling the stop async. So our generator stopped running, all right? And then again, I'm going to call start. And then our generator, once again, is up and running, all right? So that's really, really cool stuff. Now, for example, if you like to make this even more, I want to say secure, but even let's call this a bit better, in terms of controlling who can access this particular method, who can call this method, or maybe checking if this is already running or not. Now, let's say we would like to have this one additional check so that we are not going to call, let's say, start async if it's already running, all right? So we are only allowed to call this, for example, once. So if it's already running, we want to ignore the additional, let's say, start pricing request. And the same for stop pricing. If it's already stopped, we don't want to call this stop once again if it's not running, right, already. So what we can do is we could provide some very simple, let's say, synchronization mechanism. Because as you can imagine, since ASP.NET Core is multi-threaded, within the single channel scope, it won't be an issue, right? Because the channel is thread safe and it won't be an issue. But if we were to provide some maybe additional ways to talk to our background service, maybe additional channels, or maybe you like to control this generator component from the other places within our API, you can imagine that there'll be a possibility of multiple requests, multiple parallel requests, trying to hit the same instance of the component, which in our case is not really, let's say, thread safe. So let's say trying to write some values to is running Boolean field from multiple threads at the same time, wouldn't be the best idea, right? It could produce some very weird values, and calling these methods from multiple threads could be, for example, dangerous or could introduce bugs in our system. So let's say you want to be able to control it here and want some kind of a very lightweight synchronization mechanism. So we don't want multiple threads, for example, to be able to call our start async or stop async at the same time. So what I'm going to do is the following. I'm going to make this private field. Let's call it running status. So it's going to be, as you can imagine, something like 1 or 0, right? And we'll see in a moment why this is an integer, not a Boolean value. So I'm going to now add two methods here down below. The first one I will call something like the start generator async. Okay, generator async. And the second one I'm going to call stop generator async, like this. All right. And instead of calling our generator from this execute async directly, I'm just going to either call this method or this private method within our execute async here and here. And what I'm going to do is the following. So if I want to start it, I'm going to change whether this is already running or not. And in order to make it thread safe, so even if there will be, let's say, multiple pull requests being sent through different channels to the same background service, and we'll need to figure out whether we can, let's say, run this or not in some kind of thread safe manner, we could use something like locking or other stuff. But instead of using locks, I'm going to use this interlocked. And the interlocked is a very simple and atomic safe way to, for example, add, increment, exchange, compare different kind of values. So here I'm going to do the following. I want to exchange our running status, so our integer value, which can have either 0 or 1, so disabled, not running, or 1, enabled, already running. So I want to exchange it with the value of 1, and as you can see, this will give me back the current value. So it returns the original value. So if it's already running, if it's already equal to 1, then it means, sorry, the generator is already up and running, and I don't want to do anything. But otherwise, if it's running, what I'm going to do is I'm just going to call our pricing generator and then start async. And the same way when we want to stop our generator. So here, let me do it this way. So if I would like to exchange this value to be of 0, right? But if it's already stopped, so once again, this will give me back the original value, the current value of this running status private field. So if it's not running yet, there is, for example, no need to stop this, right? There is no need to call this stop async. But if it's already 1, this will be exchanged to the 0 value in an atomic thread safe way. And then I'm just going to call our generator stop async. So let me just put some additional logging here so we can see more stuff, what's going on here behind the scenes without a need of running our app in a debug mode. So I'm just going to put there our logger instance. Let me just pass it here. And then I'm going to log some data. So at first, let's do something like log information, pricing, background service has started. Okay. And then let me just put something like has stopped. Okay. And then finally, when we receive any kind of request, I'm just going to do something like pricing background service has received the request. And then let's just get our class name. So here I'm going to get our request get type dot name, like this. And when we want to stop or start, let me also put some breakpoint here. So there I will call something like logger, log information, pricing generator is already running. And here I'm going to log pricing generator is not running. All right, so now let's see if this is going to work. So I'm going to call this, I'm going to run this one last time, and let's see. So when we start the app, of course, nothing happens. But if I call start, let's see, we have received this request there, as you can see, right? There's the log, and we started this generator. If I will try to call this once again, let's see, I'm getting this this warning here, this logger message that this is already up and running, right? So it's already running. So I can now call stop, right? And it's good. It stopped. So there's no more generator being, updating its internal values. And then if I try to stop once again, I'm getting this warning that this is not running. So I cannot stop it anymore. And once again, I can just start it multiple times if I want to, but this is going to be started only once. So yeah, quite a lot of stuff going on within this episode. It's not all perfect. We could do better job with handling our long-running tasks, that's for sure. For now, we simply discarded these tasks, but we talked about different kind of different cool internal stuff of the .NET actually here, starting with the ASP.NET Core hosted service and then moving into our channel components and then into our Interlocked as the very lightweight kind of synchronization mechanism or kind of a way to atomically increment or decrement our, for example, numeric values. So yeah, if you're a .NET developer, I think it's worth knowing that such a nice component system APIs are somewhere out there. Okay, so that's it when it comes to the fourth episode. As you have already noticed, there is quite a lot of nice components, which once again would be just a tip of an iceberg when it comes to building, for example, some kind of more data-oriented systems, right? And you have like multiple ways of how to deal with background jobs, background services, how you could, for example, create some background tasks, running within your apps that would, for example, stream the data like in our case, or maybe subscribe the data from the other services and then consume it for some other internal purposes. So yeah, the .NET as a framework, as a platform is very rich, and we have just used stuff like hosted services, background services, channels, or even we talked briefly about synchronization mechanisms like Interlocked, and we used all these nice and rather easy to use components to build our very first kind of a dummy, but still somehow at least usable, maybe for the testing purposes, our own data feed. And now we'll be finally able to actually subscribe to this data stream in the future. So yeah, thanks for watching and see you in the next one.